Okay, so this video is meant to talk about and analyze characteristics of quadratic functions, which we call parabolas. And so with quadratic functions that are parabolas, they're going to be a vertical U-shaped graph. Quadratic also means your highest exponent of the variable is 2. So over here, we're going to focus on vertex form today. So vertex form is y equals the quantity of x minus h, quantity squared, plus k. So we're going to go over to Desmos and look at a graph here. This right here is considered our basic most graph. This is actually the parent function of quadratics. This is just like y equals x squared. So we want to analyze some things and some terms. Some of those terms we want to talk about include, over here we have them written down, an axis of symmetry, a vertex, a maximum, a minimum, a y-intercept, or x-intercept, and zeros. And so we're going to analyze those from the Desmos, and we could also do the same thing from this graph also. But we want you to be able to find these terms based on a graph as well as based on a vertex form equation. So over here what I have is this basic most. And I'm just going to start by playing around with the variable a. So as we have this value of a, it definitely changes some things about our graph. It can change how wide or narrow our parabola is. It also changes the direction of the opening. So when our value of a is negative, as I paused it right now, then your parabola opens down. And in the middle is our highest point. That's our maximum value. Okay? If our a value, is positive, then that middle point, which we call the vertex, that middle point is a minimum value. So a is our leading coefficient. It serves kind of like the slope. If it's positive, it opens up. It goes up ultimately. If it's negative, our graph opens down or goes down. And that's how we can determine from looking at the graph or looking at this particular item as a max or a min. Okay. The next thing that we're going to move around, so I'm going to take this back to like good old-fashioned where we started, and we're going to start moving around the h. So our value for h, changing where that's at, it moves it left and right. Okay, so it's x minus the value. So if I stop it somewhere, if I had this right here and our h value was a negative 4, then x minus negative 4 might be written as x plus 4 inside the parentheses. But our h value is still negative 4. It's kind of the opposite of the value you see. Okay, depending on how you look at that. Our value for k, if we play with k, k is actually going to move it around up and down. And that's our center point. Our whole graph just kind of moves around. Okay. So we're going to stop it right there. I have labeled the center value. That hk is our vertex. And what I hadn't had in here was this dotted line. This dotted line right here is our axis of symmetry. So this splits our parabola in half vertically. It is just x equals h. And all of our points are symmetric from here. They have the same value on y value on either side. Okay. So if I get rid of all of this and we look at here, okay, right now my a value is a negative, so I'm going to have a maximum value. It says x plus 5, so we can see that our vertex is going to be at negative 5, 11. And that vertex is going to be a maximum. I'm going to have a y-intercept of negative 14. So a y-intercept is just 0 is the x value. We could put 0 in place of x to find the associated y value for our y-intercept. And some places they're going to have you also, these other dots that came up are the x-intercepts. Those are sometimes called zeros or roots. And this will show you those also, or you could solve it algebraically. If I were to look at this green graph, we could also see that this one is going to have a minimum value. My vertex is at +1, -4, depending on what you're looking at. My axis of symmetry would be x equals 1. My y-intercept is at 0, -3. So if you want to pause there and try something, it's fine. Otherwise, I'm going to go through another example written out. So to summarize, okay, our axis of symmetry is x equals h. It's what splits our graph in half. Vertex is the center point, hk. A maximum happens if our value for a is a negative. That means our parabola is going to open downward, and this is the highest it goes. A minimum happens when our value of a is positive, and our graph opens up. And the y-intercept is 0, whatever. So that's another thing we look for. All right. If we were to look at this particular graph, we should be able to identify all of these things. Looking at this graph, just kidding, I'm gonna go to green. If I wanted my axis of symmetry, what I should be able to notice is right here is my vertex. That vertex has an ordered pair point of -1, -4. Which means my axis of symmetry is x equals -1. Is that a maximum or a minimum? Well, it opens up, so we're going to say it's a minimum. Or a min. And my y-intercept, this is my y-axis right here, goes down to -3. So some people will say the ordered pair, 0, -3. Other places, they're fine with you just giving the y value or the function value. Okay? And sometimes they will want you to do the same thing with max or minimum value. So my minimum value happened to be -4. Okay? We could also do this from an equation. Right? So I'm going to start off. You can have f of x. It means the same thing as y. X minus h squared plus k. So my axis of symmetry is going to be x equals that value of h. In this case, my h is just a 1. So it says x minus 1, x minus h. If you saw a plus sign, we'd have to change it. So it's going to be just x equals 1. My vertex is hk. So I have this +5 here as my k value. So I'm going to have it the ordered pair of 1, 5. And since my a value is a negative, that means it's going to open downward, and that means this is in fact a maximum. And to find my y-intercept, I'm just going to replace the x with a 0 and use the order of operations carefully, making sure to do the parentheses first, and then exponents, multiply, and add. So I'm just going to do that together. So my y-intercept is 2, or it means I'm going to have the point 0, 2 on my graph. If you wanted to graph these, you could definitely do a function chart or an XY chart, but you want to put the vertex in the middle. Since the vertex is where we're starting, we definitely want to do that. And we could put our y-intercept in there, and sometimes people just use this as enough to say, hey, if that point's there, this one's here, they might just go ahead and just sketch it off of those 2 points. Other times we can come up with more points, just saying values that are less or greater than our value. So we know this was a 2. If I put a -1 in there, I would get -3 times 4 plus 5. Again, I just replaced this x with the -1. So that's going to be a -7. So at -1, I'm down to -7. Okay, and I could go ahead and put these other points in there. But what we know is that since we have our axis of symmetry right here, the axis of symmetry isn't really part of the graph. It's just a tool we use. Because if I'm 2 spaces away there, if I go 2 spaces on this side, I'm going to have another point. And we can do our best to connect these and make our parabola. So there you have a graphic example. Parabolas in vertex form or something along those lines.